Okay, and now we are officially recording too. Okay, good. All right, so we've got x to the fourth minus 9x to the third plus 3x squared plus 11x minus 6. And our goal for this is to find the rational roots. Okay, so let's talk a minute about what the word rational means. What's a rational number? What does that refer to? All right, good. So any number that can be expressed as a fraction. Okay, so we're going to find all the roots of this equation, or of this polynomial, that can be expressed as a fraction. Okay. All right, and so like I said, you've done this before in Algebra 2. You guys did do a bit of this. So we'll see if this looks familiar to you. You're going to do factors of the last term divided by factors of the leading term. And when I talk factors on this, I mean like the coefficient, not the x, just the number itself. And by doing that, we're going to make a list of a whole bunch of numbers. And those are all going to be our potential rational roots. Okay, and then from that list, we're going to start testing each one systematically to figure out which ones work and which ones don't. Kind of like we did at the end of class yesterday, where we did synthetic division and we tested each one using synthetic division to see which ones worked and which ones didn't. Okay, so for this particular problem then, let's start with this. What are all the factors of that last term, negative 6? Go. Yeah, they have to be integers, yep. Okay, so, and I can use positive or negative of any of these numbers, right? So you said 1 and 6, so plus or minus 1, plus or minus 6. What are some other factors we can use? 2 and 3, okay. So plus or minus 2, plus or minus 3. Okay, those are all the different factors we could have from negative 6 that are integers. And then also I need to do factors of the leading term, and the leading term coefficient is just 1. And this list is going to be a lot shorter. What are my factors of 1? Just plus or minus 1. And so then what we need to do is do a combination of all of these, all the combinations of these numbers divided by these two numbers. Now, on the outset, that looks like it's going to be a whole ton, right? Because you've got 1, 2, 3, 4, 5, 6, 7, 8 numbers here divided by 2 numbers there. Every combination of that would be 8 times 2, that would be 16 different numbers. Now, the nice thing is when you divide some of these, you end up getting the same thing using different combinations. Okay? If you divide a positive by a positive, what do you get? Positive. If you divide a negative by a negative, what do you get? Positive. So you're getting the same thing those two ways, right? So if we look at just like taking the plus or minus 1 and dividing it by plus or minus 1, there's really only two options there, right? Could be what or what? Positive or negative 1, right? If I take plus or minus 6 and divide it by plus or minus 1, there's really only two combinations there too, right? Plus or minus 6, okay? So normally, you would have more than just one thing here for the factors of the leading term. So maybe it would be like a plus or minus 1 and then a plus or minus 2 and some other stuff. So you're still just matching them up, but the plus and minus stuff kind of like cancels itself out a little bit. So really, by dividing these things, we're just going to test plus or minus 1, plus or minus 6, plus or minus 2, and plus or minus 3. So we got to do 8 synthetic divisions then. Okay. Now, some of you guys are like, oh, geez, 8 of them, really? Yeah, we still got to do 8, but 8's a lot better than infinity. Because at least doing this, we're able to whittle it down to 8 possibilities rather than, I don't know, a whole bunch. You need one more?
Yeah, there should be one left.
Right?
That should be it then.
Okay.
Thanks.
All right, yep, no problem. Okay, so for this one, what I'll do is let's break up the class a little bit and have you guys, like, maybe every 2 people takes a different one. So you guys right here will do positive 1, negative 1, positive 6, negative 6, positive 2, negative 2, positive 3, negative 3. Okay? So what you guys are going to do is you're going to use a synthetic division. So take the number that I just told you when I pointed to you, put it in the little box for synthetic division, and see if it's going to be a factor or not, or if it's going to be a root or not, I guess technically is what we're doing. Okay? And then I'll work them all out really quickly here. Yeah, there's some of these you get about 3 steps into it, and it's like, yeah, it's not going to work. Like I was just working on positive and negative 6, and yeah. Alright, sounds like you guys are all done, so I'm just going to finish the last one I was doing here. Answer that one. Negative 11, 22, 25, negative 50, negative 39. 2 times 39 is 78. So that's getting 72. Okay. So let's just go around the room and see if it worked or not. So positive 1, did that work? So positive 1 is a root. Negative 1, that did not work. Okay. Positive 6?
Just slightly vary off.
Yeah, slightly vary. Yep, a big remainder. Okay, negative 6? A lot of no on that one too. Yep. Positive 2? Did not work? No. Negative 2? No. Positive 3? No. Negative 3? No. Okay. So the only rational root we have for this one, and I'll show you, I did synthetic divisions here for like the first 6 of them and then got tired of it. So yeah, the only one that came out to have a remainder of 0 was this first one. Okay? So the only rational root for this particular function is x equals 1. Okay? Now, I could have gone through, and done the rest of these synthetic divisions. If I was doing this problem by myself, I'd have to do all of them, but x equals 1. That's it. And sometimes it might seem kind of frustrating to you, but at least you're arriving at an answer. Sometimes none of them work. You don't have any. So the particular function cannot be factored at all. There are no rational roots whatsoever, and that's your answer. Okay? Now, this being said, does that mean that there are no other roots whatsoever for this particular function? There's just no more rational roots. Right. So we don't know about the other ones necessarily with this one because we can't really go any further with this. We can take out the 1 and see what's left over, but then we're kind of stuck. So I'll do one more of these with you guys. It's not going to be quite as large this time around. But on this one, we're going to take a look at a couple of roots, and we're going to see if we can take out all the rational roots and then use that to find more that are not necessarily rational roots. Okay? So let me quick get this all together here. Well, try a different one here. So, sorry, I got to quick multiply stuff together here to get the new one.